This next talk will focus on one specific computer vision application, real-world dehazing, and demonstrate how synthetic images from a 3D rendering system can train a dehazing network and achieve excellent results. With MS and PhD degrees at De La Salle University, our speaker is currently the lab head of the Graphics, Animation, Multimedia, and Entertainment Lab at DLSU-CCS. Please welcome, De La Salle University Assistant Professor, Mr. Neil Del Gallego.
Hello, good afternoon, SoftCon participants. So, give me a moment to set up my slides. Okay, so again, good afternoon. So, kita naman ba yung slides ko? So, before I begin, okay naman? So, okay, sige. So, without further ado, so I'll begin my topic for SoftCon 2023, which is basically the 5 years worth of research in my PhD. So, it's called Virtual 3D Environments for Gathering Synthetic Images for Deep Learning. So, image dehazing as example. So, I'm currently with De La Salle University. So our outline for our talk will cover four major topics, which is yung large data set problem in deep learning, and then how can we use synthetic data for deep learning, and a deep dive in a specific application that I have researched on, so which is dehazing. And then we proceed with the conclusion. So as we all know, in the advent of artificial intelligence, so you need lots and lots of data. So I'm under the domain of computer vision. So we are training, or I am researching on how computers can look and detect objects as if they were humans. Okay, so for example, in object recognition or license plate recognition. So it's under the field of computer vision. So the problem here is, in reality, if let's say I want to have a data set of all possible Philippine jeepneys and all of their license plates. So in reality, you need to have those data. So you need to basically gather or manually take photos of jeepneys in the wild. So pupunta ka pa sa EDSA, pupunta ka pa sa iba't ibang locations just to get samples or training samples for your AI. So that is actually tedious to do. So the alternative to that is, what if we could simulate it with visual observations? So in computer graphics and in my field, so in game development, so I have basically merged the two disciplines together. So the game development practice of creating 3D virtual worlds. So we use that as our test bed for training computer vision model or AI, in the hopes that it could recognize objects in the real world. So for example, I could design my own suburbs modeled or inspired by a certain city and then attempt to apply it in real world examples. So yun yung, that's what we're doing in a nutshell. And then the advantage of this is, if you're going to take cameras or if you're going to take pictures using your own mobile phones or other cameras, you would have uncontrolled degradation, which is could be noise, blur, and fog. So the advantage of this, if you simulate it in a virtual environment, you can actually control it. So you could simulate blur, noise, and fog the same way as this, or you could actually clean it to your own desire. So you could actually have something that's very clean. So it's either you could simulate noise, blur, and fog on its own, or you can pair it with very clean data or assemble it with very clean data. So all of those is possible in a virtual environment or in a 3D world. And for supervised learning, you always need to have paired data sets. So yeah, so in the virtual world, you could actually gather more conveniently paired samples if needed. So this is yung overall proposed framework that we have been doing. So me and in Game Lab, we're in our research area spans under synthetic image generation, wherein we're using a game engine or any other rendering system for us to create an arbitrary number of scenes. And then from those scenes, we will have like a procedural scene generation technique to allow us to generate a diverse amount of images for a possible computer vision task. So yeah. So now let's tackle more about synthetic data. So in literature on in related work, what are the other applications or possible opportunities for using purely synthetic data in computer vision? So for example, we have pedestrian detection and tracking. So if we want to detect the behaviors of crowds, understand the behavior of pedestrians in mass transportations, so where do crowds typically go or converge? So you could simulate that from a virtual world. So there's actually a data set of that from the work of one. So are the images familiar to you? So to those who are playing games, this is from Grand Theft Auto 5. Okay, so it's a very famous AAA game and has been used as a test bed for computer vision training as well. And then from Apple, from the company of Apple, they have created a photorealistic synthetic dataset for indoor scene understanding. So they have manually created all of these seemingly photorealistic assets for various indoor vision applications. So yeah. And then for simulations, you could actually simulate physics. So for example, if you want to detect objects in a cluttered environment, so the best way to do that is to simulate physics in a virtual world and use your vision model or train your vision model using these examples. And then here's another application which could be from robotics. So in this research, so an overview, they have recorded an animal, so a dog. They recorded how a dog moves, and since they have the motion capture data, they further refined yung motion capture data. Kasi for example, yung actual robot, wala naman siyang tail. So they need to refine their motion to accommodate those changes and further train yung parang yung hardware limitations ng robot. So for example, yung joints niyan, as you notice here, medyo fixed as compared to a real animal. So this is one possible application of that. Okay. So and then in 3D object localization, so if you assemble everything or create a virtual urban city in a game engine such as Unity or Unreal, you could perform something like this, wherein if I just give a single image of a real world image, okay, or from a camera or let's say an autonomous vehicle, you could, let's say, identify ano yung distance between A and C since you have a plot of your 3D environment. Okay, so you have trained a vision model that allows you to plot yung 3D scenery just from the images. So for you to do that, again, you need lots of data, and the most convenient way to do that is to simulate it in a virtual world or in a rendering system. So in this topic, so I'm just going to focus or a deep dive in one of the areas of image enhancement. So we call it dehazing. Okay. So ano ba yung dehazing? So in other words, it's defogging or remove the fog from an input image. So haze is caused by atmospheric particles that scatter around the scene and degrade the visibility of objects. So here are some examples from benchmark dataset. So our goal is to remove, okay? So to enhance the image and remove the fog, okay? So yun yun, okay? So some background. So if we want to simulate haze, or if we want to gather lots and lots of data about hazy and clear images, if we're going to do this in the real world, one example of that is to do it using LiDAR maps, or LiDAR for the depth maps. So you can use depth maps to simulate haze. But the problem here, as you notice, is due to hardware limitations and interactions with light dun sa LiDAR sensor, it would cause sparse areas to appear, or yung may mga empty pixels. So that's a reality. So it's a limitation of the hardware. So you would have something like this, yung mga blank areas. So there's an area in computer vision that attempts to complete yung pixels dyan. So you would now have something like this, okay? So that's one way to do it. Another way to do it is you're really going to wait for a foggy weather, mag-gather ka ng images, and then you would have to wait for the clear weather and then gather another set of clear images. So that's another manual and tedious task. So our highlights is in our research, we are the first. So yes, we are the first to present a method of using synthetic images for a physics-based dazing task where we are using only a virtual environment. So kami yung, so wala pang gumagawa niyan. So kami yung first, fortunately, nauna kami mag-publish ng research results that attempts to do it. So, and then our method achieves competitive performance with other state-of-the-art methods. And then lastly, yung dataset that accompany this is also publicly, sorry, available. Sige. So, I'm not going to do a very, very comprehensive talk about yung training methodology. So, this is basically just exposing and sharing ano yung parang ginawa namin in a high level. Okay, so you could always refer to the scientific paper for more details. Ayan, so what we have here is what you call the atmospheric scattering model. So ito yung, this is how you model haze. Okay, so this is based on physics. So this is the equation. So I have here the captured image. Ito yung nare-receive ng cameras natin if may fog. And then if we want to, so this is what we want. So we want the clear scene. Okay. So since we have the clear scene, so according here, this is the equation. It's multiplied by the transmission map, and there's an additive term called the airline. So our dehazing task is defined as follows. So we're going to use letters to further as convention. So H here refers to the hazy image, C is yung clear, and then T is yung transmission map, and A is yung airline. So medyo clear po ba? So yung ibang letters dyan, for example, D of C refers to the depth map. So I will expand on that later. So but to explain this equation, anong purpose niyan? So ito yung nare-receive ng camera nyo. So this is yung fog. And then according to this model, if you want to get the clear scene, meron kang transmission map. So ano muna yung transmission map? So transmission map, based on this visualization, it refers to kung saan nagsisettle yung particles. So in the atmosphere, there can be so many minute particles scattered around, especially during foggy scenarios or smoke. So the darker the pixel is, mas concentrated doon yung particles. Okay, so mas dense yung fog dun sa area. And then what you have here is the airline. Okay, so if you have yung sunlight, so a single light here, so syempre mag-shoot yan ng mga light rays, and you have here yung fog. So based on light transport, So in the world of optics and physics, so according to the laws of light, magbabounce off yan to different areas, yung ibang particles inside the smoke ma-absorb. So this is what we see as a phenomenon kapag sa real world na yung light here mas pronounced or mas scattered kasi due to the area or the dense area of the fog. Okay, so it means here na kapag lighter yung color, mas maliwanag. So di ba ganun naman sa real world fog if you have, let's say, yung sa street light. So kapag medyo foggy yung surrounding, let's say nasa Baguio ka, you would see na parang merong God rays dun sa fog area. So this is it. So ito yung representation niya. So it's called yung air light. Okay? So if we have this term, so this is element by element multiplication lang naman and then plus. So parang find j of x. Yun lang naman. So it's really just a linear algebra as long as you have yung necessary information like transmission map and airline. Okay? Sige. So if may questions sa dulo tayo mag-Q&A. So ngayon, since we have those, we can train a supervised learning approach. So meaning ng supervised, paired data. So everything is paired. So for example, this is just an example. So the hazy image can be paired with any of the combinations here to allow us to train a vision model out of it. Okay. So now, before I proceed with the network architecture, so let's first have a brief background on image-to-image translation. So I have a poll here. I just want to get an idea sa audience if aware ba sila sa concept ng image-to-image translation. So you may vote, maybe 30 seconds, and then from that, I'll adjust my talk kung yung iba hindi pa naririnig yun. Okay? Yeah. So 15 seconds. So please cast your votes. So, but based on the looks of it, mukhang more than 90% hindi ata narinig pa. So I'll definitely introduce. Okay, ano ba ang meaning ng image-to-image translation? Okay, sige. So let us close the poll. Okay, so yun yung results. Ayan. So kita naman na ulit yung screen. Sige. So, what's an image-to-image translation? So, ang best example dyan, since computer vision, is magpakita na lang ako ng images. So, our core method is based on image-to-image translation. So, ganito siya. No? So, in computer vision, there is an area wherein if you provide an image, ita-translate siya to another image. So, that's the most straightforward way to explain it. And there can be very interesting domains to that. So for example, if I just give a label or a color-coded label, ipo-provide niya ano yung corresponding real-world image. So there are some applications to that. Another is, for example, meron kang snow. I want to convert it into a nighttime snowy weather. So you would have something like this. And then if you have a black and white photo, merong colorization, ibibigay sa iyo ano yung colored ano niya. And then this one is you have a virtual game from GTA 5. You would translate it into a real world image or a real world resemblance from another data set called cityscapes. Okay, so ganyan yung mga applications niya. So there. So you have a new terminology, so it's image-to-image translation. And ang mga pioneers dyan is itong mga works na to in literature. So image-to-image translation with conditional adversarial networks and enhancing photorealism enhancement. Okay, so we have a prototype of that. So for example, DLSU Archer's Eye, if we just feed it with GTA 5 examples, we have trained like to produce clearer images. So as you notice, yung color at style niyan, medyo similar dito sa color distribution ng GTA 5. And the advantage of that is mas clear yung ibang mga images. Okay. So now let's go back to dehazing. So anong image to image translation task 'yan? So I give a hazy image from a synthetic version. Ang output nun is dehaze or a clear image. Okay? So image to image. So how do we gather data sets? So we have here our own virtual world, which is procedurally generated. So we are fortunate to have an API for this. So we call it the Fantastic City Generator. So given this, we apply global illumination and post-processing effect to make it realistic. Okay, so this is a computer graphics terminology. And then we save the images and it would produce us itong set na to. So we have yung synthetic na ayan, and then this one, and then ito yung depth. Okay, may corresponding depth maps. And then we use it for the dehazing task. So basically, ito yung clear image, letter C. Ito yung letter U. So I will expand ano yung letter U later. And you have here yung depth map, which is yung D. So balik lang kayo dun sa atmospheric scattering equation. So if we go back there, ito. So balik lang kayo dyan. So i-plug in nyo lang yung mga ano na yon, yung mga images na yon, and you could basically simulate haze. Okay? So there. So ngayon, what's the motivation behind it? So why are we using synthetic images? So why not real-world images? Okay. So our main motivation lies with the behavior of the depth maps. Okay. So yung depth maps, they can easily be captured with a shader program. So in computer graphics, since everything has been assembled in 3D, you would have a corresponding depth map. So meaning ng lighter pixels, mas malapit sila sa camera. Okay? So the darker the pixels, syempre mas malayo. Okay? So in computer graphics, since you have assembled your 3D world yourself, you have complete information of their 3D coordinates. So essentially, what happens here is your depth maps are complete. Okay? So from this, ito yung sa synthetic counterpart, and sa real world, ang limitation kasi ng real world gathering of depth maps is understandably they will be sparse. Okay, so limitation talaga siya ng sensor sa real world. Ayan, so some works would rely on image depth for generating hazy images because it's inversely proportional to the transmission map. So the problem with real world image depth is it's sparse, so you would need a depth completion network to infer the remaining depth pixels. So parang what happens here is if you're going to train a dehazing network, parang meron ka ng margin of error from your depth completion network kasi nagpe-predict ka lang din naman ng missing pixels. So you have already added a layer of a certain margin of error on top of your whatever reconstruction error from your dehazing network. So what if you just provide the 100% complete depth maps? So that completely eliminates yung problem. So am I making sense? So ayun. So mas complete yung depth maps. Okay? So and then on numerous experiments, we have identified na since we are using a 3D virtual world, meron naman sa computer graphics na mga technique na path tracing. So yung mga ray tracing nowadays. So if you have an RTX graphics card, so meron ng ray tracing, meron na ring global illumination. So it basically bridges the gap on creating photorealistic images. So mas dumadali ngayon yung training since they're almost close to real world examples na. So now, if we combined it with a technique called style transfer, so meaning ng style transfer here is, this is yung real world dataset namin. So we call it Places 365. So it's a database of parang 2 million random images in the internet. So we have that, and we're basically parang learning the style of Places 365 to copy over on top uh, of our synthetic image para mas magmukha siyang realistic. Okay? So para when we train an AI, ito yung nakikita niya. In essence, we are basically parang the AI is already parang trying to also look into examples of Places 365. Okay? Okay, so ito na yung letter U na naiwan sa equation. So it's U of C. So this is yung unlit image priors. So ang definition yan, so kami yung nag-formulate ng unlit image priors. So we are the first to basically invent yung ganyang terminology sa vision. So to explain this in layman's term, this is yung original image ng synthetic counterpart. What's happening here is, as you notice, parang nag-mute yung colors or lumiliit yung color distribution. So what's happening here is mas nagmumukha siyang dull, di ba? So mas less yung color impact. So in our experiments, we found that it's better to do this. So let me explain why. Ang best explanation ko dyan is we have let's say, for example, you have a set of images. You plot yung RGB values nila, okay, in just let's say an arbitrary graph. So let's say ito yung mga intensities niya. Okay, so kalat-kalat siya. So this is yung original distribution. So we could train a network na it attempts to parang try to cover or model everything inside of it. So however, ang limitation niyan is definitely you would require more training power, more computational complexity kasi mas malaki or mas complex yung distribution ng RGB. So it's going to become you would require tons and tons of training time for a vision model to properly model ano yung RGB distribution. Okay? So in our experiments, it's far better to basically from this, parang i-compact mo siya, yung distribution niya, to a very limited amount or very limited yung Gaussian distribution. So ngayon, parang yung network, mas madali sa kanya mag-learn dahil it's basically just like a circular distribution na lang yung ilo-learn. Okay? So if you visualize this in a histogram, ito yung original color distribution. Mas madali sa vision na mas kaunti yung colors niya for it to learn quickly. So what if we just squash everything dito sa gitna? Okay? So magiging ganyan yung mas madali, okay, sa AI mag-train ng very compact yung distribution ng samples. Okay. So if you're wondering how we came up with this is based on tons and tons of experiments. So trial and error siya until we came up with this kind of method. Okay, ayun. So hindi siya parang biglaan. So numerous trial and error din. So ngayon, ito yung dataset comparison from other models. So ito yung sa amin. Okay. Ayan, so in literature, iba-iba naman. So kami yung nag-propose na completely synthetic. So now, if we want to design a dehazing network, so meron na tayong images, how would we now design our network? Okay, so we have here yung naive approach. Okay, so in the naive approach, we can generate the following clear image by simply feeding it to a encoder and decoder network na end-to-end yung approach. Okay, so where C denotes the reconstructed clear image. So this is a very standard loss function sa supervised learning. So we're basically training it to minimize yung reconstruction difference ng hazy and ng clear images. Okay? So ang problem dyan, if we just do it like this, is sobrang layo ng distribution ng synthetic images sa real world. Okay? So it would cause overfitting. So it's because the style and color of real-world hazy images do not match the virtual environment scene composition. So as humans, by just looking at it, so visual observation pa lang, malayo na siya. So hindi talaga siya mag-work sa real-world examples. So again, as a machine learning researcher, after numerous thousands of experiments, ito yung best network architecture that we came up with. So I'm not going to further expound on it. So kasi it's staggered into 5 networks, wherein each network have their own purpose. So parang 5 AI. So may 5 AI na bawat isa may kanya-kanya silang ginagawa. Okay. So we have here yung style transfer, the haze generation, the unlit image extraction, the transmission map estimation, and the atmospheric map estimation. So once na-complete na yan, so dito sa inference stage, ayusin ko lang po. Sa inference stage, i-plug in mo lang yung mga na-predict na images, you would now have yung clear version. So ayan. So we call it physics-based dehazing. So recall na yung atmospheric scattering model is given by this equation. So ginawa ko lang siyang letters. So since meron na tayong transmission map, meron rin tayong meron rin tayong air light, meron rin tayong hazy image, find C. Okay, so what is C? So we extract C by this equation. And then, since recall we have full depth data, it would output us yung clear image. Okay? So now, our final results. So the best model that we could train with that shows na ito yung performance. So we have PSNR and SSIM. So ito, the higher or close to infinity, the better. SSIM, the closer to 1, yung maximum, the better. Okay. So you would notice here na, for example, there are some works na very specialized sila sa certain dataset. So for example, you have here yung outdoor, and you have here yung indoor dataset, and another dataset na recite yung pangalan. So you would notice that there are some related work na very specialized sila sa certain dataset. And then dito sa iHaze, for example, si DA Dehaze ang leading, sa Reside si Physics Dehaze. So ano yung claim namin? So our claim is across the 3 known benchmarking datasets, kami yung pinaka-flexible. Okay, so we may not be the leading, but lahat ng known benchmarking datasets, we are above average of all the state-of-the-art in literature. Ayan. So now, let us see yung visual results. So ito yung sa amin. So ito yung hazy examples. And then ito yung ground truth. So ito yung walang haze. So as you notice, medyo close na yung performance. And then sa Reside, ito yung one of our best examples. Ito yung mga hazy examples. For example, yung iba nagha-hallucinate na, nag-iiba yung colors. And ito halos parang nawala yung color niya. In our case, kung ano yung original color niya, na-maintain siya. And everything here is closer to the ground truth examples. Okay, so what about in the wild? So what about if we use completely different images? So weeks before this talk, nag-try ako kumuha ng mga pictures uh, from the internet in our country. So recall, di ba, meron tayong mga fog and fog incidents or weather during these past few weeks. So I've tried using our own model. So this is one of the examples. So I forgot saan to. So I believe baka Makati to. So ito yung hazy and ito yung dehaze. So definitely mas kita lahat. But future improvements could be ano yung color ng sky. So yung sky hindi pa siya kaya kasi masyado siyang malayo sa camera. But everything that's nearer to the camera, mas nakikita na siya. And then this one is from DLSU. So I forgot which date. So ito yung original. And then if we attempt to use our model, ito yung magiging dehaze output. So I hope kita yung difference. So ito yung original. And then ito yung dehaze. Okay? Ayan. So next, ito yung mga mga very difficult examples. This one, so I forgot saan to. So galing lang to sa colleague ko. So you have here, ito yung reference lang. Ito yung clear example. Ito yung hazy picture niya. So dinihaze ko siya. Yes, nadidehaze siya, but of course, hindi hirap siya dito, dun sa skyline. Okay? So as researchers, we label this as future work. Okay, future work. Ayan. Okay, so now we'll proceed with our conclusion. So we have several time for Q&A. So I intentionally allotted more time sa Q&A. So if you want to know ano yung other details, we'll reserve it sa Q&A. So first is in the chat, nag-provide na ako ng public link. So all of the necessary implementation details is in this paper. So it's published in Signal Processing. So it is a high impact journal with 16% acceptance rate. Ayan. So fortunate kami, nakapasok kami dyan. And now, saan pa ba siya pwede? No? So after this, this is just one area. So I am personally actively researching on synthetic deep learning. So marami pa siyang possible avenues. So because if you merge yung field ng computer graphics, game development, and vision, it would actually allow you to solve a lot of known real-world vision problems. So for example here, you can control the material appearances of objects. So for example here, nag-iba yung material niya. And this one, naging parang mas rock yung texture, or mas malinis yung rock na texture. And then again, we have here a synthetic indoor example from the Apple company. So possible avenues niyan are, for example, retexturing. So if I give you a video like this, so this is from the work of one. So it's real-time global illumination, decomposition of video. So pwede kang magpalit ng texture dun sa clothing. So, and then this one is relighting. So we could check this link very quickly. So this is from the works of Adobe. So let me put it here. Ayan. Wait lang. Okay, so if we go towards the later part of the slides, ayan, so meron silang, dito na lang tayo. So yan yung original image, so may capability siya na pwede kang mag-relight. So even yung cast shadows niya nababago. Okay? And ayan, so we have here this image here, nababago rin yung, nasisimulate niya rin yung paano mag-cast yung light. Okay, so you could visit this page. So it's called Outcast outdoor single image relighting with cast shadow. So works from University College London and Adobe. So ayan, so in their architecture, they're also using synthetic data. So inaral nila paano yung light sa computer graphics and how it actually works in the real world. Surprisingly, pareho sila sa phenomenon ng real-world light transport. And it allows you to do these kinds of things. Ayan. Okay? So going back to our slides, uh, so in the long-term outlook of this is definitely if you are a game developer or a creative professional, you could actually work with AI engineers to solve a real-world problem. So again, referring to the Grand Theft Auto 5 na example, pwede kang mag-identify ng mga objects as well. And then another is this one. So it provides you necessary information about your game, which you could actually apply to real-world vision applications. And then another workflow for this is if you have a game engine, you design your own virtual world, i-simulate nyo lahat sa virtual world, and then try to train an AI model that attempts to solve a real-world problem. So pwedeng ganun yung approach. Okay? So for example, this one, you have these kinds of materials. It would allow you to create photorealistic examples. So this easily solves the problem with large data sets. Kasi everything here could be merely sampled from a pool of pre-existing materials, and it allows you to create more diverse levels or virtual worlds. Ayan. So with that, so that ends my talk. So if you just want to know more about what we do, what our research is, so you could always visit and like Game Lab. So that ends my talk. So we could now discuss, we can have our Q&A.
Okay, thank you so much, Neil, for your presentation. Why don't we show our appreciation to Neil by clicking emojis? All right, thank you. Now we have some questions here from the audience. So let me start with the first one. So this is from Michael. So the question is, how do you ensure your model doesn't hallucinate synthetic examples to your real-world images, especially since you're using purely synthetic images?
Okay, so actually very good question. So we could further expound dyan sa word na yan. So it's fortunate alam ni Mike ano yung hallucination na terminology. So first, ano ba yung image hallucination? So meaning, so remember we are training in synthetic images. So ibig sabihin, yung AI prone siya mag-produce ng synthetic images. So ang analogy niyan is if I train my AI using cartoon images, for example, to recognize faces, definitely hindi niya kaya mag-recognize ng cartoon, ng real-world faces kasi nga nasa puro cartoon images yung binigay. So the same goes with hallucination. Okay, so meaning baka isipin ng AI na synthetic pa rin siya, so it must produce a synthetic image pa rin, hindi yung real world. Okay, so how do we address that? Recall na in our talk we have yung unlit image prior. So that greatly helps mitigate yung problem. It's because what's happening there is if you have itong mga synthetic images, ito yung color distribution nila, pinapaliit yung color distribution. And in essence, when you compare it to real-world examples, mas madali siya i-train. Okay? Kasi nga, parang what what we're doing is, we are essentially removing yung light, yung different variations and noise possibly incurred during the synthetic image generation process. So nangyayari parang nagiging agnostic yung model namin on color. Okay? So parang since agnostic na siya sa color, mas madali ngayon na kahit anong images na yung iba to, regardless of color, malalaman niya kung may fog ba siya or wala. So that's one way that we have done it. So I hope that answers yung question niya, ni Mike. Thank you.
All right, thank you, Neil. So we have another question here from Amos. The question is interesting to see this approach of utilizing a 3D rendering tool to prepare enough training data, a usual headache in ML training. So, what would be your tips in terms of resources for those who are interested to do the same approach?
Uh, okay, so a good question, no? So ang parang ang naging uh, counter or new way of thinking to that if you're going to do synthetic image generation or synthetic data generation is you must fully understand ano yung parang mathematical equation ng iyong problem. So again, for example, in dehazing, we have yung atmospheric scattering model. So it's a well-established equation. And now, since we have that kind of model, we're just going to simulate different types of variables dun sa mathematical equation na yun. So the same principle applies to other types of uh, problems as long as you have a well-established foundation or mathematical equation for that. So another example is pwedeng siguro yung image enhancement or removing blur. So may corresponding mathematical equation yon na ito yung parang blur kernel and all of that. So if you have that kind of complete equation or well-posed equation, mag-generate ka lang ng mga variables to it and it would basically provide you with a comprehensive set of examples. So, ayun. And lastly, definitely, a knowledge of rendering systems. So, like, pwede muna mag-start sa Unity engine, sa Unreal, and towards yung mga low-level like OpenGL, Vulkan, Blender. So yung mga yon, those are available tools for rendering. So thank you.
All right. So for our next question, this is from Kim John. So the question is, are there any considerations or best practices for ensuring the ethical and unbiased use of synthetic data in computer vision, especially when the real-world data may involve diverse or sensitive content?
Okay, so that's a good question. In fact, tinanong rin siya during my dissertation defense. So parang how sure are we na reflective siya sa real world examples? Okay? So I believe that lies now on the trust and ethical standards of the researcher themselves. For example, if I'm going to learn or train a model to learn how to detect vehicles, kuwari ganun lang, detect vehicles. So definitely, I will not feed it examples wherein yung vehicles, yung placement ng vehicles, siguro nasa sky or nasa taas ng building kasi hindi naman siya nangyayari sa real world, right? So you're not just going to blindly randomize everything. So it must also be grounded by your understanding of the real world context. So ayun. So that will definitely address yung concerns na possible ethical issues. So if you want to remove sensitive content, then the most straightforward way to that is maybe don't include it in the samples. Okay, so ayun. So intentionally omit them.
All right. So we have another question. This is from Nico. So can this tool be used to improve images by enhancing details like scratches and cracks?
I would definitely say yes. Kasi my initial hypothesis is yung scratches and cracks. Para rin siyang image eh. So you could basically parang draw ano bang representation ng crack. So baka meron siyang mathematical simulation na how do cracks appear in surfaces. So ano ba siya? Fractals ba? So ano ba yung mga noise? So what if you could simulate it? Pwede mo siya actually ilagay directly sa image. Pwede mo siyang i-overlay. So you could easily do that with a renderer again kasi everything is in 3D. So meron ka na ngayong concept of layering. So that's also possible. Yeah. Ayun.
All right. Okay. Thank you. I think that's all the question. So thank you once again, Neil, for your presentation. Now, in case you guys have more questions for Neil, you may reach out to him on our Airmeet Lounge. So you may feel free to chat with him. So before I let you go, may we please have a quick photo of just smile towards your camera and our tech team will capture it. All right, thank you. So that's all the time that we have for this session. So let's thank again Sir Neil for his presentation by clicking your heart and clapping emojis. Also, one more thing, before I let you go, did you guys know that there is a leaderboard? So you may click on the trophy icon above the air meet, so to see who's leading our leaderboard. So who among you wants to win an Alexa Echo from PSIA? Wait, well, you better rack up your points. So we also have prizes for the top 10 from Globe Business and IBM. So how do you earn this point? So and dislodge our current top three. So just update your profile, ask questions, answer polls, click emojis, visit the virtual booths, visit sponsor links, and more. In other words, engage here in Airmeet. So this will continue until tomorrow, so there's plenty of time for you to earn this point. So we will announce the winner tomorrow late afternoon. So if you have a hybrid ticket, you may download the AirMeet application from the App Store and the Google Play. So you can continue engaging in AirMeet even if you're in SMX Aura tomorrow. So thank you so much. You may now exit this session and click on the next. Bye, everyone.